we want to find the coordinates of the center of mass of the shape shown. We can see a large circle with a small circle which has been cut out. We're going to consider the center of mass of each of the circles to be a point mass. The mass of each is going to be proportional to the area. We also need to know the position of the center of mass as we consider our point mass to be at those coordinates. Let's look at the big circle and then the small circle. For the big circle, the center of mass is at the center of the circle, which is at the coordinates 4, 4. The area of the circle, the radius is 3, pi times 3 squared, is 9 pi. For the small circle, the center of mass is here, at the point 3 and upwards we have 5, so 3, 5. The radius is 1. 1 squared times pi is just pi. Now consider the composite shape, the large circle with the small one cut out. The area of the composite shape with the bit cut out is 9 pi minus pi, which is 8 pi. We don't know the coordinates of the center of mass, so we call them x bar and y bar. To find x bar, we take moments about the y-axis. We have 9 pi times 4. Strictly speaking, a moment is the weight times the distance, but we know the weight is proportional to the area, so we can use area here. The other thing to note is that, of course, the x-coordinate of 4 gives the distance from the y-axis. Look at the diagram above. We then have minus pi times 3. It's a minus because we've cut the small circle out. This must be equal to 8 pi times x bar. So we have 36 pi. Take away 3 pi is equal to 8 pi x bar, and so 33 pi is equal to 8 pi x bar. We can cancel the pi's, and then we can see that x bar is equal to 33 over 8. If we now take moments about the x-axis, we're going to get 9 pi times 4, take away pi times 5, and that must be equal to 8 pi times y bar. Remember, the individual moments of each part of the composite shape must be the same as the moment of the composite shape. So this is 36 pi. Take away 5 pi is 8 pi y bar. So 31 pi is equal to 8 pi y bar. The pi's will cancel, and then we get y bar is equal to 31 over 8. So our results were that x bar was 33 over 8 and y bar was 31 over 8. That would be here on our diagram. If we draw a line through the original two centres of mass and this one, we can see they are in a straight line. If we have two individual centres of mass, then the centre of mass of the composite would always lie on a straight line with the original two. If we also consider the position further, we can see that from the original position of x is 33/8, we've moved to the right, and that is because of the part cut out. If you divide the large circle into two halves, the composite shape now has more mass in the right half, since there's mass removed from the left half. So we'd expect the centre of mass to move to the right, towards where there is more mass. The same will also be true in a downward direction, since the bit cut out has come from the top half of the large circle.